Hey everyone, my name is Nadim Jabbour. Today I will be demonstrating my ECE 561 challenge assignment number 2, the home monitoring system with Watchdog Timer. First off, I would like to demonstrate the loading of my code onto the board for the purposes of both debugging and real-time execution. Now that the code is downloaded onto my board, I'm going to stop the debugging process and keep my board plugged just for power reasons. Now, my switch 1 represents my doorbell, and then the LED on the booster pack is going to be my activate, deactivate burglar alarm. That's my doorbell. Now also, I have the burglar alarm activate, deactivate button, which is S2. And if I tap on it, the alarm will go off. And then one more press of S2 will deactivate the alarm. Now I will be demonstrating my fire alarm. In order to do so, I brought with me a flashlight. Now the way we are detecting fire is by an ambient light exceeding a certain threshold. So when I flash the flashlight over the sensor, the fire alarm turns on. Now no matter what I press, activate, deactivate, or the doorbell itself, the fire alarm remains on. The only way to turn off the fire alarm is by resetting the system from the side. It's a little tricky where developers place their reset board. But now, as you see, the board is now reset and the fire alarm turned off, waiting for the next fire to turn back on. Now for the part that we've all been waiting for. Next, I'm going to go ahead and walk you through my code and also demonstrate an example of an analyze feature and an optimization feature. Now I'm going to run you through my code and show you my thought process and what I did to optimize my code. First off, to save a little bit of memory space, I changed all my ints into short ints, especially for the variables that do not need as much space. As you see, the only thing I left was the noise level, because the noise level has very high ranges. Now the first thing I do in my main function is I hold the watchdog timer and I initialize the clocks. In my clock, I'm setting the frequency to 8 megahertz. This is another power optimization that I've done. Instead of setting it to 64 megahertz, I try to find a value that is fast enough to capture the inputs from the environment and at the same time not slow enough to actually be able to capture it in time in case there was a fire or a loud sound. So I found that 8 megahertz works perfectly, saves us power, and our system does not have to run as fast because it's being able to do the same exact tasks as with the 64 megahertz. Now, the next thing I do is initialize my timers. To initialize my timers, for the PWM, I'm using the timer A, and I'm also using the system tick to clear my watchdog timer, as well as keep track of a few timers. And also, TA1 is not initialized right now, but this is used for the button debounce, and I will show you later on where it is being initialized and how it is being used. Next, I initialize my ports. Port 1 is mainly my switch 1 and switch 2, which I've initialized here. For my port 2, I needed to initialize the green LED, the red LED, and the buzzer on the booster pack. And these are its represented pins on the MSB432. And port 6 is going to be for my ambient light sensor. Port 4 is going to be used for my microphone input. Now, one thing that I would like to show you is initialized. So basically right here I'm initializing all my unused ports. Now what this does is it saves me power from leakage. So a thing that the compiler was advising me to do is to initialize all unused ports so that there's no leakage or parasitic current flow. And so I went ahead and did that, and that solved my issue of the leakage of current. Now, next I initialized my ADC. And then I initialized my watchdog timer. And I set it to reset at every 8,000 mega clock cycles. So basically, since my clock is running at 8 megahertz, that means every 8,192 kiloticks, that will roughly equal 1 second, and that's where I want to reset my watchdog timer in case something goes wrong and we're stuck in a loop or something out of the normal happened. This will be able to reset, and this only resets if there's something wrong. If not, I will keep on clearing the watchdog timer. Now I enable all my interrupts. I initialize the I2C communication for the ambient light sensor. I'm also initializing OPT 3001 digital ambient light sensor. Now, what I do in my code is initially I take the initial lux. So the initial lux is basically the light of the surrounding area as it is right now. So I need something to compare it to determine whether there is a fire or not. So whether I'm put into a dark room or I'm put into a light room or whatever type of room I'm putting in, I'm able to take that initial value and off of that compare to see if there's a fire. And this right here, the tone function, as you can see, the tone function basically sets my duty cycle, my time period, my clock source divider, and then it generates my PWM. Now the reason why I put this tone 000 here, this is just to go ahead and turn off the buzzer if there was a reset or we're just starting off the program from scratch. We want to turn off the buzzer. Before getting into the main loop of my system, I would like to show you my timer and port interrupt service routine. Now, I would like to start off with my port interrupt service routine. Now, basically what I'm doing is I'm setting up the interrupt service routine for the two switches on my board. And as you see, that I am both setting this depound state to 1, and I'll tell you why later. Now, the status, if the switch 1 was pressed, then we are going to head and turn on the doorbell. And if switch 2 was pressed, we are going to toggle the armed, which basically tells us if the burglar alarm was on or off, and we are going to toggle the green and red LED to switch from activate to deactivate. Now, in the timer ISR, we have our system tick, which is clearing our watchdog timer. It is also incrementing our door tone, which will be used for the doorbell later on, I will show you, and the timer, which is going to be used for our alarms. We also have the debounce timer for the switches, and once the debounce has reached 20, we go ahead and activate the switches again. So this is about a 100 millisecond delay. Now, back into our while loop, I'll show you how the debounce, if debounce state is 1, we want to switch it to debounce state 0, and we want to initialize our debounce timer. And we are only initializing our timer after the switch was been pressed to cause a debounce of approximately 100 milliseconds. So now, the next thing I do is I check for the current lux. As I told you earlier, we found the initial lux. Now we want to compare it with the current lux to see whether there's a fire or not. So we take the value of the current lux and we compare it with the initial lux. But the lux is always fluctuating, and if you move your home security system just a few inches closer toward the light, the lux could increase. So I measured the amount of lux in a regular room, and it seems like there could be a variation from anywhere between 20 to about 200, 300 based on where it is placed in the room. So the fire threshold is, in order to, when there's a fire, I realized that the lux went from being in the 20s and 100s to the thousands. So what I did is I set the fire threshold to 300. So if the initial lux, which is this lux of the surrounding environment, plus 300 is still smaller than the current lux, then that, hey, there must be a fire. Or that's when I want to go ahead and trigger my fire alarm. And I want to set my fire alarm to true, because then I want to go back down, and if the fire alarm is true, I don't want to check for a burglar alarm, or I don't want to check for a doorbell. I would like to show you real quick what I did for the fire triggered alarm. So as I showed you in the system tick, we had the timer, the alarm timer, and so basically it increments at every 100 milliseconds, and when it's at 1, I set the tone to a certain value, and then when it's at 5, I set the value to 0. So basically, we're having this fire alarm effect where it's turning on, turning off, turning on, turning off. And this is happening, the period is about approximately once every second. So once every second, it's turning on and off, on and off, on and off. And this will continue, since I set the fire alarm to 1, this will, or true, this will continue to go through this fire alarm triggered, and it will continue to turn on and off and on and off until the system is reset. Now, if there isn't a fire alarm, we need to check for the burglar alarm, and then if there's no burglar alarm, we need to check for the doorbell. So in the burglar alarm, we first checked if it's armed, because if it's not armed, we don't even want to sound the burglar alarm, because if it is activated, we get the noise level using the ADC conversion. And then we also have a noise threshold. Now this noise threshold is also used in the same way that we use the light threshold. And in order to make it sound more like a burglar alarm, what I did is instead of switching it back from on, off, I changed the pitch. So higher, lower. And this way it kind of simulates a actual fire alarm. And then the last part, which is the doorbell. Now the doorbell is using a timer, but it's not the same timer we are using for the burglar alarm and the fire alarm. But this timer is also being incremented in the system tick. So what I did is I went for 1 second at a certain tone, the next second at a lower tone, so it makes that doorbell effect for approximately 2 seconds as required by the project. Now the final thing I did to kind of optimize my speed is I realized that using a lot of the driver libraries, I a little bit longer to initialize, for example, stuff like ports or use functions. So what I ended up doing is I switched a lot of the driver libraries with the actual register operations, as seen here in the when I initialized the unutilized ports. I want to say thank you very much for listening to my demo. I hope you enjoyed it.